Welcome to another podcast. In this episode, we're going to be taking a look at what I call a two-phase annuity. Now, this is something that's not really discussed all that much in the textbook, although it is sort of hinted at here and there, and that is any annuity has two phases to it. It has a phase where you save up, which we will call the accumulation phase. So the accumulation phase is the phase over which you save up. And then you also have what's called a disbursement phase. In other words, a phase in which the money is paid out. Now, typically, you don't pay the money out as one big lump sum. Instead, you sort of set it up to where it makes sort of equal payments to you over time. That way you can continue to earn interest on the bulk of the money. And even potentially pay yourself with interest only that the money earns. That's called a perpetuity. And so I have two examples here that I want to sort of use to make this, to help make this make sense. The idea here is that we have an accumulation phase consisting of 30 years because you want to retire in 30 years. And so you start at time 0 and you end at time 30. This is the accumulation phase. This is where you're making the money. And so it has a total time of 30 years. And then you have a second phase that starts after the first phase ends. And that phase is the disbursement phase here. And depending on which problem we're looking at, the disbursement phase looks a little different. For problem 1, it's just basically asking me that I'd like to be able to make monthly withdrawals of $3,500 per month for the next 240 months. And so if I start here with a certain amount of time that I have there, then this is the first year of retirement. So this is when retirement happens, let's say. So retirement happens. And then you start and you want the money here to last for a total of 240 months, which would be another 20 years. So this process is a total of 50 years. This is a 50-year process we're describing. 30 years of work, then you retire, and then you pay yourself for the next 20 years from that retirement account. And so let's look at sort of the individual parts of this problem, starting with the accumulation phase. What do we know? Well, you know that your principal amount, the initial investment, is 0. I'm not initially investing any money over here. Next up is the, let's talk about the future value of the account. That would occur over here. So the future value of the account is the unknown. This is what some people would call the nest egg, right? This is the amount of money you want to save up for retirement. And then the present value, you're starting this process with nothing. You're making equal payments. So your payments are a certain size here, and there's a total of 360 payments being made. Equal payments at equal time periods once a month for 30 years is 360 payments. And so I kind of have to work this problem backwards, because if I think about it, then when I retire, I'm paying myself this money, and so whatever was my nest egg now becomes the present value of the disbursement phase, and the future value of the disbursement phase is 0. You're going to run out of money after 20 years of retirement. Now, you would never set up a plan to do that, but it's just going to help me to illustrate an example here. So you're going to run yourself out of money after 20 years of retirement, and the payments that you're making here are known. You're making a payment of $3,500 to yourself for a total of 240 payments. Okay, well, that is a lot of information that we have going for us. Let's talk about what we can use from that. So if I start with this, and I'll do my finance commands in red here. I'm not going to write down the annuity formulas. I'm just going to use the finance command or the calculator command. And so if I think about the disbursement phase, let's see what we have going here. The idea is we start with an unknown amount whose future value is 0. We're making payments. Now, we're making payments to ourselves, so that's positive cash flow. Making payments to ourselves in the amount of $3,500. The interest rate here is 6.5% for the entire problem, so 6.5 divided by 12 because it's monthly, and I'm going to do that for 240 months or 240 payments. And so the X value is going to be this present value here. And so if I bring in the calculator, I'll go ahead and clear out what's in there. So we'll start with a new file here. So if I bring in the calculator and type in the finance command, then just typing in each of the pieces for this problem. Total number of payments is 240. Then that tells me that I would need, in order to do this, I would need to have $469,437.52 in that account. So this would be $469,437.52 in that account. So that is the amount of money I need to have saved to retire with. So this future value of the accumulation phase, it's no longer a mystery. I know exactly how much money I need. I need to have a future value of $469,437.52. That's how you can plan for retirement. Okay, so let's talk about the finance command for the accumulation phase. The pieces that I would put in here is I have a starting value or principal value of 0. I have a future value of $469,437.52. I have a payment size that's unknown. That's what we're going to want to solve for. I have an interest rate per period of 6.5 divided by 12 again. And I'm going to do this for 360 total payments. And so once I find the payment, I'll know how much to invest each month to make this work. So if I bring the calculator back in, then we have the finance here. So I'm just going to plug these values in. And so we get negative 424.38. Now that negative shouldn't bother you. Remember, during the accumulation phase, the cash flow there suggests that the money is being invested. It's leaving you. It's going away from you. But notice the future value is positive here, so eventually it does get returned to you. So our payment is $424.38. So we would make a monthly payment of $400. Bring it back in one more time here. $424.38. So there is the two parts to that question. Okay, so that's really nice. That means that if I save $424.38 each month, make 360 payments, retire at the end of that time, I could have almost $500,000 in that account. Now this assumes 6.5% interest, but at the end of this, I will have given myself a lot of money. In fact, I will have paid myself well more than the amount of money that I put in. So let's talk about that. Let's talk about the total interest earned for this problem. So here's sort of a question. How much interest was earned over the full 50 years? Okay, well, that is an interesting question. The best way to calculate this is, remember, the interest is the future value of the account minus the principal value. And I know you're tempted to say that this is the future value of the account, and it is for the first 30 years, but the future value for the entire 50 years is how much money you walked away with. And if you look here, I paid myself $3,500 240 times. And so the future value of this account is the $3,500 I paid myself in 240 equal installments, minus the principal is the amount of money that you put in, and you paid $424.38 for 360 payments. So we'll bring the calculator back in now. If you look here, we paid ourselves $3,500 times 240, or $840,000. Over the 50 years, that's how much we were able to pay ourselves. And we only put in $424.38 times 360, or $152,776.80. So $152,776.80. And so the difference between those two would be the interest. We would have $840,000 minus 152 and change. And so the total amount there is $687,223.20. So that is the total amount of interest earned. Now, I'm going to talk about the second part of this problem in a future video, where we look at this problem instead of running out of money. Remember, that was the big problem here. I actually run out of money. And so rather than run out of money, what if I could set up what's called a perpetuity, where I live off the interest that I'm earning? And so the next video, we're going to take a look at that by extending the disbursement phase. And so I encourage you to take a look at that one. But this is a really important type of problem for me, at least to get across to you guys, that we have these two phase annuities where you accumulate money and then you can disperse money, and you can end up paying yourself, like the $840,000 here, a lot more than you put in. And this is kind of how retirement works. Over a long period of time, you're able to accumulate a lot of money through interest, and then you continue to accumulate money even after you start paying yourself in retirement, because the money that's sitting in the account still draws interest at that point. All right, thank you for watching.